It is my greatest pleasure to introduce Tom Wind, who is, I think, the #1 wind expert here in the state of Iowa. Absolutely.
Thank you.
And I've known Tom for a number of years. Tom and I were both on the Iowa Power Fund, and were instrumental in getting that $100 million that Governor Culver had asked the legislature for energy independence. And we got some really great projects going there. If you have a chance over lunch to talk to him about that, it was fabulous. It really, really was. And Tom has his own company, and he advises on wind turbines. But I think his passion really is community wind. And so I've invited him here today, and I'm just so very thrilled to introduce him and to introduce you to Lakeside Lab, which is a wonderful facility here. And you might want to talk to them a little bit about your background and the company that you have. Okay? All right. Thank you very much, Tom.
Thank you very much. Very generous and kind introduction, Pat, and not quite as good as that you portray me to be here, but and important. But nevertheless, my name is Wind, and and people say, well, did you change your name? And then I just finally give up and admit, well, I did, rather than argue with them that I really didn't. I just say, yeah, it used to be Joe Wind. But I'm an electrical engineer and graduated from Iowa State University a long time ago, 1974. Worked for electric utility for about 15 years, and then went back to the family farm, of all things, and farmed for about 5 years back at my family farm near Jefferson. And then also at the same time I started doing consulting on the side and consulted about power, energy efficiency, power, looking into the future. How do we meet our electric power needs? And then one of my clients in the town of Waverly, Iowa said, Tom, we are interested in putting up a wind turbine. Could you help us out? And I didn't know anything about wind turbines other than just a general knowledge of them. And so I helped them out, and then that launched my career into wind power. So I've been working in wind powers for about 20 years now. So, and that's what a majority of the work I do is involved with wind power. So what I want to talk to you today about is why Iowa has so many wind turbines. And then I want to talk a little bit about what we term the community-owned wind turbine projects. First of all, are all of you from Iowa?
Yes.
Okay, and all of you have seen wind farms. And how many of you have taken a tour of a wind farm?
All of us. Ask how many climbed to the top of a wind
How
turbine.
many? You're kidding me. Have some of you climbed to the top of a wind turbine?
Yes.
Oh my gosh, I can't believe that. That's amazing.
I got a bunch of them up.
So which wind farm did you go to?
We were at Iowa Lakes Community College.
Oh, okay.
In Denton, so.
Okay, very good. So that's wonderful. When I ask that question, most times I rarely get a person to raise their hand. So the way I'd like to run this today is that it's not necessary for me to get through all my slides. I got plenty of slides here. I think it's more important to answer your questions. So as we go along, if you think of a question, go ahead and answer it at the time, and I may defer you to a slide I have a little later, but let's just get the answers out while they come to you. So, why does Iowa have so many wind turbines? That's really a good question. I've been involved with the wind industry here in Iowa for such a long time. I'm kind of the right guy to answer this. There's maybe a handful of people in Iowa that can have the history of wind power going back. And I've lived part of that history and then talked to others that have been involved with it. But I first want to start with what Iowa really is like. This is the land elevation in Iowa. And the highest elevations, the brown areas, and the lowest elevations down here at Cape Cod. And as you know, it's relatively flat. It's not as hilly as this map would portray. And the elevation up here is about 1,600 feet, and it's around 800 and some feet down here. And then if you look at the other important characteristic of Iowa, it's the land cover. What is on the surface of the land? And all of the orange area in the map are crops. So it's cultivated. farm. And then the areas with a little bit of tan or lighter yellow in it are grasslands or pastures. And of course, we have a few cities in the purple there. But you can see that the vast majority of this is croplands, meaning there's not many trees there. And if you put together these two pieces of information, which would be the elevation and the land cover, along with some test towers testing the wind speed in certain areas, you can develop what we call is a wind speed map of the state of Iowa. And the windiest spots are the brown areas, and the least windy spots are blue areas. Now, how come there's a blue area right through here?
River valley.
Yeah, it's a river valley. And what do you have near river valleys?
Bluffs. Trees.
Trees, and it's lower in elevation.
Valleys.
Generally, as you go higher in elevation, the wind picks up. This is the highest spot right up there, but it's not the windiest. Generally, that would be the windiest. So why do you think this area in Pocahontas and Calhoun County is windier?
Nothing there.
Flattest.
Pardon me?
The flattest.
Yeah, and what else about it besides flatness?
No trees.
No trees. How many of you, any of you live in those counties?
Long time.
Yeah, you realize just hardly anything up there, right? It's just so flat and they're bolos in the farmstead. So, and Mid-American has built some large wind farms in there, and that's just a really great place to put wind farms. So, this is what we have as Iowans for energy resource. Now, on this map, I also plotted all the oil wells they have. They're little black dots. You see them on the map. And then you'll see the coal mines, the active coal mines we have. Those are the gray shaded areas. And then the natural gas wells that we have, and all of the fracked wells that we have, they're in blue dots on here. And then the large hydroelectric facilities, those are in green shaded areas. So there are no blue dots, there are no black dots, there are no gray areas. The point is, when you're looking at energy resources, we don't really have any. No fossil fuel resources to speak of. The hydroelectric facilities that we have are really very small compared to the energy needs we have. This is it. This is our energy resources, our most abundant energy resource. Wind power, and of course, the sun that shines on the state. So, the energy crisis first spurred us into action. How many of you were around for the 1974 energy crisis? What was it like to you? How do you characterize that?
I was working at a gas station. It was my junior year in high school. And, you know, the OPEC nations did their thing. And gas jumped from like 30-something to 55 cents. And people went absolutely nuts. And we ran out of gas. And there were lines. You know, it's down in a small town. And, you know, it's just amazing to see that kind of thing. Because, you know, you're not used to that. But we run out of gas and we'd have to put our sign up. No gas today. And people they were so upset.
Right. Anybody else have a comment about the energy crisis? Yes.
That's when we first, I started college at that time, first started talking about solar energy and wind energy about that time.
Because we almost thought that we were going to run out of gas, or we couldn't understand why there's a shortage. And the OPEC were so dependent upon overseas suppliers of energy. And here we got, why can't we use renewable energy?
And there's electric cars that were invented or implemented about that time.
Yeah.
A whole fleet of electric cars.
Yeah.
I went to Iowa State and the fella that I rode home with, I didn't have my own car, I rode home with him. We went 40 miles per hour all the way home from Iowa State to, I lived over by Macokota. 40, because that was how you got your best gas mileage.
Yeah.
I never rode with him again. and then there was the girl who had the hot date that I rode with once. We went 90 miles an hour from Ames to Clarence, right on 30. I never rode with her again either. We made that trip in an hour and a half. It was scary.
That wasn't an energy crisis.
Wasn't that about the time when we, I guess it was Nixon, established the 55-mile-an-hour speed limit.
Yeah, that was in response to the energy crisis.
What was the speed limit previous to that?
Well, we were just talking about the other day.
60.
It was higher than, wasn't it 70 on state highways?
But the, like the
75.
common like this, 86 was 60 miles an hour.
Yeah,
Yeah.
depending where you were at.
Yeah.
So, you know, because Iowa has had essentially no usable fossil fuels, we had a couple of small coal mines that were really very coal. The Iowa DNR formed this energy bureau, and it started, you know, studying this and talking about it and preaching and put out a report every year. Here's what we need to do. Here's what we need to do. They started a long-term education process that that made a difference in the state of Iowa. And then the Iowa legislature responded. It was 1983, after about 2 energy crises that we had. They came up with the Renewable Energy Portfolio Standard. In other words, it was a mandate that required 2% of the electricity that the utilities sold was to come from renewable energy. That'd be about 250 megawatts of wind turbines. And at the time that was passed, it was very controversial. No state had ever required its utilities to do such a thing. Now in California, they had some wind turbines. The first wind farms were installed, you know, about this time or a little bit below, before 1983. But they were not mandated, they were incentivized through very generous tax credits that the state had passed. So when this happened, this was very controversial. And as such, there was a period, what we call, of discussion after that. Utilities simply didn't want to do it. They said, hey, this is impractical, it's going to cost too much, ratepayers don't want this, you know, all those things that happened. So as a result, nothing really happened for a while. And it was the Spirit Lake School District, you know, right here. Harold Overman, the superintendent, he started the ball rolling in Iowa with wind power. Strange that you'd have all these utilities and lots of municipals, lots of cities, and who takes the first step? A school district. Why would a school district want to put up a wind turbine? What do they know about wind turbine? They're not in the business of generating their own electricity. But Harold was strong-willed. He had to have been strong-willed because it was he was the first entity in the state to do this. It was 1992, and it was a very difficult process. And difficult because the utility said, you can't do this. It's not going to work, it's not going to pay for itself. And there was a kind of a very difficult negotiation in there. Had not Harold kind of pulled some political moves on the utility, it wouldn't have happened. So it was Harold Overman's, you know, maybe overbearing personality, might not be the right way to say it, but his determination to get it done. So they installed the first wind turbine in 1992. It cost about $250,000, $250,000. They got a state grant, federal grant for part of it, and they got a low interest loan from the state of Iowa. The project was successful because of 2 factors. One is that the state of Iowa required utilities to offer net metering. And the second is the structure of Alliance Electric. Alliance is the utility that serves that area. First of all, net metering is just a policy that says if you put up a wind turbine, there's going to be times when your wind turbine is going to generate more power than you need. And that power is going to go backwards through the meter onto the grid. And a net metering policy says, okay, utility, when the power goes backwards, you give the customer credit for those kilowatt hours. And then when the wind's not blowing and you need power, you let the customer have those kilowatt hours back for free. You're kind of using the utility to bank that. That makes a big difference in the economics. It really does. And so net metering was a policy that Iowa established. And the second was Alliance Electric rate. And all I need to tell you is that most large facilities, like schools, they buy electricity. There's a couple parts in their electric bill, 3 main components. And one of them is just the kilowatt hours that they use to their meter. The second one is the highest rate that they use during the month, or the peak. And because of that, if you have tried to make a wind turbine economic on a customer that's got these two parts of their electric rate, it just won't work. Because the wind doesn't blow every day. The wind doesn't reduce the peak load of the facility, because there'll be some day during the month when the wind's not blowing and the facility's at its peak and this electric bill will be higher. So it worked out that these two factors lined up for this particular school district, and it made it work. And it was all these little things that occurred. Having Harold Overman, having the net metering, having Alliance Electric just designed that particular way that the turbine actually paid for itself in about 6 to 7 years, which was a very fast payback period. Very fast payback period. Most utility investments in generation are depreciated over a minimum of 20 to 25 years. And here we have an electric generator that paid for itself in 7 years. So, more small wind turbine projects were built. George Braxma, have anybody of you heard of him before? He lives near Allendorf, and he installed 5 65 kilowatt rebuilt turbines. And these came from California. He installed them on his farm right south of Allendorf. These were not fancy turbines. These were taken from California, taken out of service, brought back to Iowa. And they were lattice towers, and they weren't fancy or anything like that. But he installed them and he sold the power to Alliant Utilities. And then, the next year, 1983, a retired banker and assistant donated 2 wind turbines to Nevada. One to the county, Story County Hospital in Nevada, and the second one to the school system. That's quite a donation. Most people give money. This guy gave wind turbines. Why? He just liked wind turbines. He thought they were cool. And what gift can I give that keeps on giving, each year? Rather than giving a pot of money and have it be all spent, a wind turbine provides an ongoing gift. How many of you have seen the wind turbines there in Nevada? And there's 2 now at the school and then 1 at the hospital. And then, and the one by the hospital, it's really not by the hospital, it's by the sewage treatment plant. And they worked out a deal. At the hospital, they couldn't install it, but the sewage treatment plant had room. Then they said, I'll tell you what, we'll make that a deal. We'll put it at the sewage treatment plant, and whatever money we save in the power bill, our power bill, we'll just write you a check and send it to the hospital. And so that's what they ended up doing. So more projects followed, 24 turbines by 1998. And so here's a little graph showing the wind turbines that were installed. Here's the Spirit Lake schools, the Proximas. Nevada had 2 wind turbines there at the hospital and the school. And you can see here's a farmer, Monty Miller, over by Brett, that's here installed. Schaefer Manufacturing, that's Adair. How many of you seen the wind turbine at Adair, the little one that was right by the interstate there? Guess what? Have any of you guys seen it lately? It's gone. It's now serving a new life, I think, up in Alaska. The owners sold the wind turbine. Why did they sell the wind turbine? Well, did you remember where that wind turbine was installed? It was about 25 feet from the building. And there was a little manufacturing building right there. And they had it installed back in 1994. In all these years, it never caused a problem, but it was about 2 years ago, a chunk of ice came off the blade, flung over the building into the parking lot on the north side, and cracked a window on a car. And that really spooked them. And they thought, well, this could be dangerous. And so the insurance company also said, yeah, this could be dangerous. You ought to do something about it. So they turned the wind turbine off for the rest of the winter, in fact. And then they turned it on again next summer and said, let's just sell this to someplace else. They installed it too close to a building. You know, modern standards would say, no, you got to keep wind turbines away from people because things can happen for safety purpose. But it was remarkable that it went from 1994 to about 2010 before they ever had a problem. So that's 16 years before they ever had a problem with ice on it. But anyway, that wind turbine is now gone and it's someplace else. But over this period of time, in 1988, there was a total of 24 wind turbines that were installed. And look at the number of schools that were involved in here that got wind turbines. And then after 1998, a few more schools even installed wind turbines. But I think this is strange that the wind industry in Iowa was led by a school and other individual people here. Did you have a question?
I do. Do you know what happens to the wind turbines to these schools that kind of disappear, like Central of Fenton? They're not in anymore. Does Alliant take them back over, or?
No, usually not. The Alliant wouldn't have any use for a small turbine like that. And in some cases, the school the turbines, that one was a rebuilt one out of California, so it was on its second life. And it just becomes more costly and to maintain, and so they just take them down. They find somebody that will buy it, and then they'll give it to them for next to nothing usually, and then they just remove it. Any other questions? So all of these wind turbines, we call them community-owned wind turbines because the community owned them, or individuals in the community. Not large companies, not utilities, but individuals. George Braxman had a lot of nerve to put up those first turbines there. And individual people like the guy that owned the Boondocks Motel, he just loved wind turbines. So he wanted his own. So remember that the state of Iowa, the legislature mandated that 2% of the electricity come from wind turbines. So how did we, Iowa, get to 2%? Because in 1983, after they passed the law, nothing happened. So the Iowa Utility Board started a process, and it took them a while. And then there were legislative challenges. Once the law was passed, the utilities tried to undo the law, say, we don't need this. And so every year they would try to undo the law. Then there were legal challenges. And utilities did not want the wind power, and they challenged it at the federal level, the Federal Energy Regulatory Commission. They challenged it at the state level, the district court level. They challenged it everywhere. And then the legislature said, hey, this is going a little slow. Maybe we should talk about providing some incentives. And so they came up with a reduction in property taxes. They said, okay, the property taxes are paid on everything. Let's give them a break on property taxes. Let's phase the property tax in over 7 years, and then let's cap it about at 30% of full value. And that is a reduction probably of about 50% in property taxes over the life of a wind turbine. And then they eliminated the sales tax. They had already eliminated sales tax on some large equipment. And they said, you don't need to pay the 5 or 6% sales tax on a wind turbine. And then they said, okay, we have this power plant siting law, that if you're going to build a big power plant, you got to submit an application, go through this long process, and you know what? Don't bother us with a wind farm. If you can work out a deal with the farmers and everybody's happy, and everybody signs on the dotted line, we don't care. Do you know how much easier that makes the world when you can do that yourself and negotiate something and make everybody happy, and then you don't have to get any more approvals? So that made a big difference. And then Iowa's 3 major utilities, after fighting this for such a long time, they ran out of all of their options, and they finally said, okay, uncle, we give up. And then they contracted with 3 developers, 2 developers in 1999, or the year before, and then they finally installed the wind turbines in 1999. And they installed a total of 230 megawatts. And all of this power was sold to the 3 main utilities that we had at that time. So they were under long-term contract. And these installations finally fulfilled the utilities' obligations. They're done, they thought. Got it over with. We're paying for this power. We hope this never happens again. And so here is the first wind turbine that was installed by Spirit Lake Schools right there. And then 2 wind farms were installed by Storm Lake. How many of you have seen the original wind turbines that were installed west of Storm Lake? What's different about those wind turbines?
They have an open base, it's a lattice structure.
Yeah, it's a lattice tower. All new wind turbines now are tubular. Why do you think they did that?
Because that's what the farmers around had, that's the type of windmills they had.
No, that wasn't the reason.
Easy to construct.
Cheap, yeah.
Cheap, you're right. Cheap.
Inexpensive.
First cost was cheap. But guess what they learned after that?
Maintenance.
It wasn't so cheap after a while. Well, what do you think happened?
Safety.
Well,
Fasteners came loose.
Fasteners came loose. They started, what are these nuts doing up around here? You know?
Vibrations.
They're falling up and they're coming loose. So they had to go and tighten, retighten, torque all the bolts, nuts all the way, put little, what do you call it, lock nuts on there.
Yep.
Yep. And then guess what else they found out that's not very nice about open lattice towers?
Corrosive.
Pardon me?
Corrosive.
No? No? What else?
Fix the wind.
No?
Flexes.
Well, they flex, but that's not a problem.
Things climbed up them.
No? Keep close. Come on, keep going along that line. What if you were a maintenance wind technician and it was 20 degrees below zero outside?
Cold.
And you had to climb outside, and the higher you get, the faster the wind blows. Just think of the wind chill you'd have just getting up to the nacelle. So the guys didn't like them very well. Guess what? That was the last lattice towers in the United States that were installed. And what else is unique about those wind turbines? What color are the blades? They were originally black. Why did they did black? Most wind turbine blades are white. Why did these guys put up black?
Absorb this. I didn't think that they
Absorb,
absorb
yeah.
the heat. Yeah.
Absorb heat,
Make them longer, make them think that
For,
to go around faster.
Reduce
Dry. Oh.
did you say icing?
Yeah.
Yeah. The meteorologists doing studies, and they build little test towers up with a little anemometer, say, hey, sometimes those anemometer cups freeze solid and they won't turn. And, we don't want to affect the blades because a little coating of ice, just like an airplane wing, if you get a little coating of ice, you can't fly because it affects the aerodynamics. It does the same thing with the wind turbine. It just cuts the power in half. So let's make them black, let the sun melt the ice off. And so, well, that was the last black blades built in the United States because the black helped a little bit, but it also caused problems because in the summer it just absorbed heat and it just was harder on the material and blades. So very unique wind farm. So 2 wind farms were built right there, and then the 3rd wind farm was over here. It's about 257 turbines here and 56 turbines over here. How many have seen this wind farm south of Clear Lake? 56 turbines. I thought that was a big deal when that went in. Well, going beyond 2%. Well, the major utilities fought the initial requirement, but then what happened next was what I call magic. In 2001, 2 years later, a 4th wind farm of 80 megawatts was installed north of Clear Lake called the Top of Iowa Wind Farm. Many of you may have seen that one, north of Clear Lake. Yeah. And then in 2002, a 5th wind farm installed west of Garner in Hancock County. A gazillion wind turbines there, 148 660 kilowatt turbines. And then a 6th wind farm in 2003, west of where we are right now. How many have seen the wind farm just west of here? The first GE turbines. So why did these happen? All of this power was sold to one utility. It was sold to Alliant Energy primarily, and to a couple cooperatives.
Wasn't the one that was originally built in Clear Lake, the electricity was sold to a power company in Florida?
Power company. Near Clear Lake? Power
Yeah,
company
I
in
thought the one
Florida.
that went up at Clear Lake, the electricity was all going to Florida.
It was a Florida company that built it.
Okay.
Yeah. But the power was sold to Alliant. So what happened was the utility said, hey, this wind power is okay, we can manage it, and the price, the wind turbines are getting more efficient, the price of wind turbines are coming down, and the same guys that built the first wind farms and sold the power said, hey, do you want some more? We got a better price for you this time. And so it turned out that it was economic. So the utility said, hey, yeah, I think we can take some more of this. So all of those were built for private developers. So by the end of 2003, there were 600 turbines in Iowa. Or we got about 4% of our electricity from wind turbines by that year. So more policy changes were proposed by the utility board. One was the siting of 34.5 feet electric transmission lines. Before, you had to turn in a franchise application in the state, you go through a hearing process, and they say, okay, yeah, you can build a transmission line at this point. And they said, oh, the utility board said, oh, forget it. All the wind turbines are connected by 34.5 kV lines, but they're buried underground. They don't affect anybody. So they said, don't bother us with this. If you can get an agreement with the local landowner, that's good. So that change made it easier to build wind farms. And then the legislature allowed utilities to own wind turbines. Initially they said, oh, you can't own them, you just have to buy it from somebody else. Mid-American said, hey, I think this is a good deal for us and our customers. We'd like to own them. So they passed legislation to allow that to happen. So all of this resulted in Mid-American investing in wind generation and Alliant. And it turns out they are the two big champions of wind power in the state of Iowa. It's the two big utilities. And then Iowa provided an incentive for what we call community-owned wind generation, which was a 10-year, 1.5 cent per kilowatt sellable tax credit. That's about $70,000 a year for a big wind turbine as a state tax credit. And that was for small projects, for an individual or a farmer or a business that wants to install a wind turbine, they can get that tax credit. So, and then after that, the Iowa Power Fund, which Pat referred to, they invested in demonstration research and education. They put some money aside, gave it to the university, said, hey, help everybody out, study the problems and issues we have with wind power, and provide solutions. So today, we have 3,200 wind turbines totaling 5,100 megawatts. 25% of the electricity coming out of that socket right there, on average around the state, 25% coming out of the socket is from wind power. That is the highest the second highest in the United States. Well, no, it's the highest this year. It's the highest this year. Here's a map showing where all the wind turbines are. If you want to count, there's 30,200 dots on this map. They're not oil wells. They're better than oil wells because they're renewable and they don't pollute. And for example, right here in Story County, there's about 200 turbines here, although you can't tell that. And then if there's an individual turbines right here, I made the dots bigger so that you can see them. So we have individual large turbines now, not little turbines, large turbines here. And these are the community wind projects where farmers get together and they own wind turbines. And right here in Greene County, I live right here. And I have part ownership in the middle of 7 turbines right there, and I also, my family owns some of this wind generation right here, and that's right north of Grand Junction, Iowa. I'm invested in wind generation. I put my money into wind generation. I'm part of the community-owned wind generation. So, a lot of wind turbines.
Tom, I have a question for you.
Yes.
I'm from Calhoun County.
Yes.
If you look at Calhoun County, and you look at the wind potential map there. However, if you look at where the turbines are sited, there are virtually none in Calhoun County.
Okay.
I mean, we have them directly north of us, just south of Pocahontas, and we have them, southeast of us, just north of Carroll, between Carroll and Breda.
Yeah.
Hundreds of them, but
Why
none
did you
in
get
Calhoun
sheeted
County.
out? You get sheeted, you get any.
We have none.
Why?
Yeah, that's my question.
Oh. Why do you think?
Mid-American.
That's the best place to put it, right there, Calhoun County, besides Pocahontas. They just don't like the board of supervisors there?
Transmission problems?
Yeah. Transmission. They ran out of transmission lines. If they want more, they gotta build new transmission lines just to get the power out of there. Do you know how much power Calhoun County uses? I would guess about 30 megawatts.
Yeah, I know.
Yeah, here, right here, there's about 200 megawatts right there. So that power's just got to get the heck out of there because people don't use it there. So that's the problem. In fact, we're going to have a slide that talks about that in just a second. Now, having talked about small turbines, these are 1 to 100 kilowatts. These are the ones you find up at a farm, small, where they put one up and running like a hog confinement building, or one for a homeowner. These are where the small turbines are. The big circles are not related to, they're related to the size. For example, this is a 100 kilowatt turbine right there. And you see they're clustered all over the state of Iowa. And they're not necessarily in the windy areas, because the reason people put these in is because they want to. They like wind turbines, and they just think it's a neat thing. And a lot of farmers now, some of the farmers are starting to, where they have a hog confinement or something like that, they're finding that they can put in like a 50 kilowatt turbine and make that big. So this is a lot of small wind turbines. No other state, I think, has this many small wind turbines other than maybe California. So what does Iowa do to support wind power? So the Iowa Wind Energy Association started about 5 years ago, and they're very active. They promote wind energy. They have a part-time lobbyist. You know, I'm a member. I pay dues, and we also support federal policy initiatives. So doing that and saying, hey, this is what we need to do to continue to grow wind power in the state, that's an important thing to do. Somebody needs to do that. The legislature is politically divided right now, as you know, Democrats, Republicans, and sometimes that's good and sometimes that's bad. If you have policies that are good right now and you don't want them to change, then sometimes it's okay to have it divided, because they can't get anything done, you know. So that's one advantage of having it politically divided. But we found out that wind power is generally supported by both Republicans and Democrats. And then another thing, I want to see a lot of wind turbines every day. I want to ask you, how many of you, and just be very truthful and blunt with me, how many of you don't like to see a wind turbine on the horizon? Don't like to see a wind turbine out your back window, because it's different. It's not natural. It's not the green prairie. How many of you don't prefer that? There.
I don't prefer to see the whole big field though.
Yeah, it's
Just
just,
one or two is fine, but if I see it across the whole field, it kind of takes away
it
the
does.
serenity of it.
If forever change, it changes the horizon for probably 30 years or whatever they're going to be up. I agree. So, but generally, we had 1 person out of 30 here that objected to it. And I would guess, you know, that might be reflective in general that most Iowans, you know, it's not a big deal. And generally, Iowans don't complain about wind energy, just like Texans don't complain about oil wells. Because we now realize that why wind energy, why do they use it? Because it helps provide electricity. And believe it or not, it has kept your electric bills down. And there's proof of that. At first, we didn't know if wind turbines were going to raise your electric rates or lower them. But it turns out that wind power is keeping electric rates down. The proof is in. Now, why is Iowa number 3 in the United States with wind power? We're behind Texas is number 1, we're behind California. Those are big states with a lot of people. Why is Iowa number 3? Well, we had all these state policies. But there's a little bit bigger story to it. Here's a map of the wind speed in the United States. The purple is the best. This is the worst. Iowa's got some good wind speed, but not as good as North Dakota and South Dakota and Kansas and Nebraska. Those states have a lot of purple land, meaning they have the best wind resources. But Iowa's got enough. And if you look at where the people live, Iowa's got more people. Green is people. How many people we got out here in the States? People, they're the ones that use the power. But Iowa's got kind of a mix of people and the good wind resources. And as a result, all these docks here are proposed wind farms that have been proposed, some of them are built. So it's a combination of having people that need electricity and having, you know, reasonably good wind resources. Now, how many of you have seen pictures like this? You know, I don't know if this is India, where it is, I think it is. And, you know, and this is electricity and telephone and communication cables, and that's what you call congested grid. Our transmission grid is right here, and it's the blue and the red lines. And you can see that where we have the best wind resources up here, you know, this blue line that we've got going through here, and this blue line carries about 200 megawatts each. 200 megawatt lines. These red lines are about 700 megawatt lines, but there's no red line going through here. And all of these lines generally carry power from the west to the east where the people are. Here's where most people use electricity. Get up into Blackhawk, Waterloo, Lynn County, Cedar Rapids, Johnson County over here, and Davenport. Most electricity is used this side of the state. And the purpose of these transmission lines is to carry electricity from coal-fired generation and hydroelectric power out in the west over there. So they don't have a lot of extra room on these lines for new power. And so we need more transmission lines so that, what's your name in Calhoun County?
John.
John. So that John can get his wind farm. Now, this is a map showing the price of power. Nobody sees this map, except if you're a power user. And it shows the price of power. For example, right at this particular time, there's a real-time price. Every 5 minutes, the price of power in the grid changes. And for example, right at this particular time, it was like 1.5 cents a kilowatt hour in Michigan and 1.5 cents in Indiana. And the price of power is about the same everywhere in this area. Here's a day, and this happens quite often, where there's a big difference in the price of power. And up in here, we have a high price of power over Wisconsin. This could be like 50 cents a kilowatt hour. And here, it was a negative 1 cent or a half a cent a kilowatt hour. So the price of power is negative. Wait a minute. How could the price of power be negative?
They're generating a surplus of energy more than what they use.
Yeah, so what's it negative mean? It's negative is if you rebate. It's like a rebate. In fact, if you generate power into the grid, you have to pay them to take the power. That's terrible. So but they worked out a way to give price signals to say when to generate and not to generate. So negative here, positive here. What this is telling us is that, boy, if you had a power line that went from here to here to transport extra power, which is caused by wind turbines, here you'd make a fortune. So that's the purpose of having real-time pricing. And as a result, a number of power lines have been proposed to be built. For example, here's another spot right, look at that, Indiana. That's blue, that's negative, the cost of power is negative there. Why is that? Anybody want to take a guess why there's a little spot in Indiana where the price of power is negative?
Wind turbines.
Yeah. How many have been to Indiana and seen this? They built a bunch of wind farms, didn't have it there before, and built the wind turbines. So what's a wind turbine do? It lowers the cost of power on the grid. Wind turbines lower the cost of power on the grid. And so we have lower cost power here, higher cost here, built transmission lines into the areas. So we have the mechanism now to do that, and so that's what's happening. And so today in Iowa, we have these proposed lines. I'm sorry that line didn't make it to Calhoun County, but it's close enough. It's close enough that wind turbines will probably be built here, and a little line will be built over here to this major transmission line. So this is what's being proposed to accommodate more wind power. So how much wind power can Iowa really use? Well, today we have about 5,100 megawatts. Projects that have been announced over the next 2 years that will bring us up to about 6,500 megawatts, which will be about a third of our electricity in just 2 short years will be from wind power. And then we've talked about proposed lines, a number of proposed lines that would bring the total up to about 8,500 megawatts if they all get built. And this would provide about 50% of electricity needs. No other state will ever be that high, but Iowa could get there.
Question before you move on to that next
Yep.
bullet point. that last part there, you say, although part of that will be going to the states to the east and south of Iowa.
Yes.
I'm surprised that they're not trying to keep it so that more of this power stays in the state to power the whole state.
Yeah.
Why not? Why not?
Well, because the
Politics, money.
Nope. Iowa is not by itself in the grid. If you look at the grid, we work with about 10 states, what we call the Midwest Independent System Operator, MISO. In fact, MISO tells everybody in this 6-state area when all the power plant owners when to generate, who should generate, and everybody bids a price in. Hey, today I'll generate power and I'll charge you 3 cents a kilowatt hour. It's a bidding process, and everybody bids into a group. So if you look at the power grid, there's no boundaries for Iowa. So it's just part of a bigger area. And so if more generation is put in here, some of it will go to other areas, just because it's cheaper in Iowa than it is in other areas, that power will go there. So it's because of economics, they work together and erase the state boundaries there. Does that make sense? And then the Iowa Wind Energy Association said 10,000 megawatts by 2020. That's where our goal is, and 20,000 megawatts. Will Iowa ever reach these goals? I don't think so. I don't think so. Because I think we're going to discover a new energy source. So I think we're on the cusp of finding it right now, and I'm going to a conference in July, in 2 weeks, and we're going to be talking about that energy source. Anyway.
Care to expand
Well, after I get done with wind power, and then we'll talk about what I see coming.
Maybe after lunch.
After lunch. Hold that question though.
Quick question. You want to elaborate on the DC line? Where's that proposed route?
There's 2 proposed routes. One is across the northern part of Iowa, and it would be like the top 2, the second tier counties down, go from the northwest corner, O'Brien County, and take off and go over to Wisconsin.
Where in Wisconsin, like?
If we want to hold our questions, we're going to have a speaker on that DC line.
Oh, is that right?
Yeah, we've got a speaker.
And which company is that? Who would that be?
We're doing the Rock Island Clean Line.
Yeah.
Yeah.
He'll tell you a lot more than I'll go to. So that's one of the lines. There's several across the United States that are being proposed. And that's, they've been spending millions and millions of dollars. Hopefully they can get that done. Switch gears. What is community wind power? Well, it is a community wind project like a single turbine. Like here's one at Waverly. How many of you have seen this right northeast of Waverly? Yep, 900 kilowatt turbine there. And the city of Waverly put that up because they believed in wind power. They wanted to use more power from renewable energy resources. Forest City, how many have seen the wind turbine in Forest City? And how about Eldora? How many of you seen the wind turbine at Eldora? Only one person. That was a project I worked on.
I'm from Minnesota and I went to school in Drake, so I drove by it.
Oh, you did? Okay.
when I went home, so.
Paid for itself for 7 years. And then here's a wind project that I was involved with. 7 people part owners with a corporation for 7 large turbines. Here's 2 up in Minnesota, Fairmont. Here's one of the first wind turbines in Iowa. This is by the town, Royal, the Royals. Yeah, Royal, the town of Royal, Iowa. It was a rebuilt turbine, not too cool looking turbine, but it was innovative for a small school to put that wind turbine in. And then here's another school in Minnesota, Lockheed Parle, that installed a wind turbine several years ago. So there are 12 Iowa schools and colleges, and 5 in Minnesota that have wind turbines. And they all occurred because of supportive public policies. We talked about these already. But the state says we need to encourage this. Let's do these things to support schools that want to do that. And they all end up saving significant amounts in their power bills. And one key thing that I've discovered in all the projects I've worked on is that there's usually one guy, one person that shepherds this project through, that just refuses to give up. He's the champion. And it happens every project I've ever seen. It's one guy that just will not give up and say, we need to do this, we need to do this. So, and then we have wind turbines at farms. Here's one in southeast Iowa, and generally the farms put them up because they just save enough electricity in their power bill to pay for them. Oftentimes the farmer likes wind turbines, and so he's willing to, maybe do a project that other farmers wouldn't do. He's willing to take a little lower return on it, a little longer payback. But and here's one of the first large wind turbines put up by a farmer, a 1,500 kilowatt turbine near Armstrong, Iowa. And he actually wanted to use this power to power a bunch of buildings. You can't see them all here, but there's a farrowing facility there. But it turned out that it just wasn't economic to offset his power bills. Instead, he just sold all the power to the utility under a long-term contract. It just worked out better that way financially for him. So farms use it. Businesses, we saw the wind turbine at Adair that's no longer there. Look at how close that is. No engineer in his right mind would put a wind turbine that close. He'd fear the liability of something going on. And the economics of these depend in part on where it's at. There's the Boondocks one at the motel. They've had a number of mechanical problems with that one over the years. But generally, I found that the projects for businesses don't work because it's real simple. Does anybody want to take a guess why businesses choose not to invest in wind turbines?
Maintenance,
Nope.
too much cost of maintenance.
Nope.
It's too long term.
Too long term? Meaning what?
Like it takes too long to get a return on your investments. Businesses operate like on a quarterly profit model, so.
Businesses like to get their money back in 1 or 2 or 3 or 4 years, right? Most businesses, corporations, wind turbines, the best payback I've ever seen is like a 7-year payback. Most of them are 10 or 15-year paybacks. So businesses, not that they don't want to do it. I've done a lot of feasibility studies. Well, I've done one for Walmart, for one of their distribution centers. They look at the payback and says, well, we'd be crazy to do this. We have other places to put our money where we can get our money back in, 18 months. Why would we invest in a wind turbine? So it's the payback. So then we have wind turbines owned by cities. Wall Lake. I worked with the city council up there. This was a fun deal. These people said, we're going to do this. And they, as a result, I went too fast here. As a result, they ran into a problem. There was a height restriction due to the local airport. How many of you have been in Wall Lake? To the south, there's a little creek valley there, and you kind of go up the hill as you're going north, and here's this town kind of at the edge of the creek valley. And remember, have you seen the wind turbine at Wall Lake? Mm-hmm. It's kind of uphill a little bit. And if you're coming on that highway, coming from the south in Wall Lake, there's an airport right here, a runway. And if you look at the runway and look at the wind turbine, it's lined right up. And normally you have to be like 5 miles away from the end of a runway to put up a wind turbine. I mean, because they just don't want anything in the glide path. So there's a wind turbine there, the airport's still there. What do you think they did to get around that? Because the FAA said, no, you can't do this, you can't do this. So how did the city council was so determined to do this? What do you think they did? The airport's still there.
So you have to fly in from a different direction.
They changed the airport from a public use to a private use. And then the federal government doesn't regulate. And why did they do that? Well, there was only 2 guys that flew into the airport. And one of the guys is on the city council. And they asked him, Joe, if we put this wind turbine up here, you think you could miss it? And then shoot, yes, it's no big deal.
So what came first at Wall Lake, the ethanol plant that's down there or the wind turbine?
I don't know. Do you know when the ethanol plant went in?
I don't. We visited there, that's why I know it's there.
Where is the ethanol plant from the town there?
It's on the south east side of town.
I think it was the wind turbine first. Because I don't remember the ethanol plant being there when I was working on the project. And then we have rural electric cooperatives. They often have long-term supply contracts to buy power. And so it's sometimes difficult for them to figure out how to incorporate a wind turbine. But we had one, Iowa Lakes Electric Cooperative, up in Estherville. They served this ethanol cooperative. And what a neat idea. Renewable energy for a renewable fuel. So they put in those 6 wind turbines. It's the first cooperative to really invest in wind generation in the United States. So they did that. So there's 2 facilities like this that Iowa Lakes did.
There was 7 in that wind farm, wasn't there?
Yeah, you're right, 7.
You can see there's a stack.
Yeah.
Okay, you're right, 7. Yep.
Yeah.
And then Farmers Electric Cooperative, and down here in Greenfield, Iowa. Worked with some farmers. I worked on this project. Fascinating project. Here, this farmer, Randy Cavanis. He's a big old guy. You know, he didn't go to college or anything, and he started out broke, poor, and now he owns like 2,000 acres of land. Anyway, he's just one of those guys that's determined to do things. And he has organized 8 projects like this, 8 single turbines, like $3 million a piece there. And he gets people together and they put money in a pot, typically $15,000 a piece or to $35,000 a share, depending upon the project. They put it in a pot and then they borrow money and then they build a turbine. This one guy is responsible for developing those 8 turbine projects. And they worked cooperatively with electric utility and they said, hey, we think this is a good deal for you as a utility and your customers. And the utility agreed, and so those projects came about. So the town of Fontenelle, the town of Greenfield, and the rural electric cooperative here in the town of Wildwood, pretty much all the power down in that little area is pretty much all comes from wind power. But the economics for municipal and cooperative wind projects are not as good as they are for most. Utilities are willing to take longer term paybacks. Typically 15 or 20-year paybacks. And sometimes a utility, they can't, because lots of utilities like the town of Lenox, they're non-profit. They can't use tax credits. And so it's more difficult to get the projects to be economic. So they have a more difficult time of making the projects economically feasible. And so I found that it's usually some guy in the utility, involved with the utility, is the reason it goes. For example, the town of Lenox, it was the guy that it was the pharmacist that ran the Rexall. Have you heard of the Rexall pharmacy? He ran the Rexall pharmacy. And he was on the board, the little board of trustees for the electric plant, and he started harping about, guys, we need to do something for our little town. Our little town's going to die. We need to do something. And so he promoted this idea of wind turbine. And the manager of the electric utility, Dave Ferris, he called me up and said, Tom, I know you involved in wind generation. I need to have you do a feasibility study for the town of Lenox to prove that it doesn't make sense for us to put up a wind turbine. And so I did a study, and it was, it was a little marginal, but it would work. And lo and behold, today there's a wind turbine there. Why? Because of the pharmacist. In every one of these projects, it's the same story. So, is the town of Lenox going to get their money back? Yes. That turbine will probably pay back in about 12 years. And so it's close to being paid back now. Any questions? Okay. Let's get through this here. So state policies are key to community wind. Policies are required because usually if you want to put, for example, here's that first wind turbine that was installed. It's just 5 miles from here. It's a 225 kilowatt that Harold Overland got in the ground for those various schools. That's not the windiest spot in Iowa. And buying one wind turbine is a lot more expensive than buying 100 wind turbines. And hauling a big crane in here to install one wind turbine costs more than if you can haul a crane in and install 100 wind turbines like that. And so there's single turbine projects, or one turbine at a time, they cost more per turbine because of economies of scale. So there wouldn't be very many of these turbines if we didn't have single turbines like this, if we didn't have state policies that supported it. And so the state of Iowa legislature said, hey, this is important, we think this has value to the state, and we think in the long run they pay for themselves. So policies, the state of Iowa has passed these policies involving net billing and tax credits, and they justify it because they say that these local projects return more money to the community, and they do. So state policy is needed, net metering, we need to somehow address this problem with the demand charges, the peak cost in your power bill for larger facilities. There's state production incentives. That's the project that I'm involved with. It receives the state production incentives, and there's other incentives that have been passed to make these smaller projects work.
So Tom, those
Yes.
are the policies that are needed. How likely are we to see those policies enacted, and what can our 16 teachers do to encourage their local legislators to support that kind of policy?
Well, Iowa has done most of these already.
We have.
Yes, this is the only one that is we've not addressed. For example, Grinnell College. How many of you been to Grinnell College? Did any of you go to Grinnell College? They've been trying to do a large wind turbine because their president signed a commitment that yes, Grinnell College will reduce its carbon footprint, and just like Luther College has. And after a number of studies, Grinnell College said, hey, besides changing out light bulbs and changing it to fluorescent and using efficiency, that's the cheapest thing we can do. After that, the next cheapest thing we can do to reduce our carbon footprint is put up a big wind turbine. But the economics weren't very good because they put it behind the meter so they'll reduce their purchases from Alliant. But there'll be some days when the wind turbine doesn't blow and the college will set a peak usage for that day, and then they'll pay on that peak usage for the month. So it's the fact that there's no credit for the wind turbines being able to, the wind turbines simply just don't offset the billing, the demand charges. So I think one state has addressed this. I think this is the state of Massachusetts that has addressed this issue. And so if you look at all of the policies that are out there to encourage community wind power, Iowa's done most of them. You know, and we have a home run if we address that one issue with the demand charge. So what happens is that large customers, people who use a lot of electricity, it's difficult for them, for the payback, difficult for them to justify investing in wind turbines because of the payback. So what could we do? Just make sure that the legislature doesn't undo any of these, I guess is the best thing. You know, I can't complain as an Iowan about what Iowa does for supporting wind power. We're really a very good state.
What's going to happen to the wind industry if all the incentives go away? And do you think that would ever happen?
It will happen. It will happen. And the price of wind power has been coming down. From the time in California, when the first wind turbines were installed out there, they were running 30 cents a kilowatt hour. Today, a large wind farm, a new wind farm in Iowa, is about 3.5 cents a kilowatt hour. If the new coal-fired power plant that Alliant wanted to build, which they backed away from, was going to be 10 cents a kilowatt hour. A nuclear power plant was likely to be something over 10 cents a kilowatt hour. Wind power is 3.5. That's with incentive. So you take the incentive away and you add about 2 cents. So it'd be like 5.5 cents without the incentive. So, is that competitive? I think so. So we're about there. We're just about there. And as far as the incentives for community wind, I think if you take those incentives away, they'll probably, you won't see very many more community wind. They're just a little bit more expensive. But that's all right. We still get a lot of our electricity from wind power. So there will come a day, and I think it should happen too, that, and I think Obama has, you know, he's brought up this issue with incentives for the oil industry. And he says, you know, there's tax incentives for the oil and fossil fuel industries. They've been on the books for a long time. If you want to do away with that, then that's fine. But if you don't want to do away with that, then you need to also provide incentives for renewable energy. You need to put them on a level playing field for tax incentive wise. So he's saying either get rid of these or keep giving the incentives for renewable energy. And that makes sense to me. So I think the day will come that everybody will get their incentives taken away. Well, I think this is the last slide. Federal policies. This is detailed stuff that normally I wouldn't talk to you. So, the last slide I have is state legislatures need to be convinced that the benefits from local ownership of wind generation offset the cost of incentives from mandates. We made this case to the state legislatures in the state of Iowa, and they agreed, and so that's why we have the state 1.5 cent tax credit. They said it was worth it to the state. Here's a view off the top of the wind turbine. If you climb the wind turbine, you saw a view like this. This is in the fall. This is a wind turbine in Armstrong, Iowa. What a wonderful view. I just love, every time I climb a wind turbine, I get at the top of the nacelle. I sit up there, and I try to sit up there for a few minutes. And I look at the shadow of the blade going across the crops. And I look and see how many water towers I can see in the distance. And you see the shades of different green of Iowa. It's just a beautiful sight. So that's my presentation.
And I suppose we should probably break and take Tom over to the dining hall for lunch. And
We can put our other one on if you actually want to see one thing. Actually, this one,
Yeah.
this one's kind of a dead run here. Yeah.
That'll work.
There we go.
That's why we're needed that picture.
And all it is the bottom of a water bottle.
That you're using to build a wind turbine?
Yes.
That's awesome.
The blade, that is.
How much power have you guys generated?
2.88 volts, 14.91 milliamps.
Yeah.
Wow.
Ooh, we have a problem with this engine.
Carter. I set a 27 milliamp reading a moment ago.
Okay. Are you going to teach your students how to do this in the fall?
That's my plan, yes. I'm planning on, I teach several subjects, and one of them is physical science, which is a freshman course. And the way I teach that course, the way I'm required to teach in order to get all the standards and benchmarks in, I have to teach a trimester of earth science, a trimester of chemistry, and a trimester of physics.
Okay.
And so I'm wanting to incorporate this energy in with both the earth science trimester and the physics trimester. Because during the earth science trimester, we can learn about the water cycle, the carbon cycle, and incorporate how these sources of energy would reduce on the carbon dioxide load of the earth. Then I would also be using during the cycle for physics how energy and power and electricity work, and how by harnessing the wind and the sun's energy, we can turn this into electricity into renewable resources.
It's pretty exciting.
That then hence turn back and they hence then turn back and they affect the carbon dioxide cycle, hopefully reducing the load on that, reducing the load on electricity for everyone, cheaper electricity, renewable resources, rather than having to rely on fossil fuels and coal. Well, I should say coal is a fossil fuel.
Yeah.
In other words, you know what I mean, having to rely on fossil fuels.
Where do you teach?
East Buchanan and Winthrop, Iowa. I teach, I'm at the high school, so I teach at East Buchanan High School, grades 9 through 12.
Okay.
I teach AP chemistry, regular chemistry, physics, physical science, a one-term astronomy course, and a two-term biology 2 course.
Okay. You teach all those classes I struggled with in high school.
I'm half of my science department.
That's impressive.
Yeah.
It's important then that you introduce this stuff, isn't it?
Yes, definitely. Well, the way the Iowa Corps is starting to move, especially going towards next generation science standards, wanting to incorporate those next gen science standards in the engineering design component of those next gen science standards, I think this will be a perfect way to get them to work on designing things. I really try to incorporate a 5E learning cycle into my classroom, and I think projects like this would be the perfect part of the elaborate cycle where they're having to actually build and design something in order to take the concepts that they've already learned and have begun to, well, maybe not quite master yet, but this is a really good way to apply the concepts that they've learned. That's where I'm hoping to go with this.
Thank you.
You're welcome. We can put our other one on if you actually want to see one action. This one, this one's kind of a dead run here.
That'll work.
There we go.
That's why we're needed that attention.
And all it is the bottom of a water bottle.
That you're using to build a wind turbine?
Yes.
That's awesome.
The blade, that is.
How much power have you guys generated?
2.88 volts, 14.91 milliamps.
Yeah.
Wow.
Ooh, we have a problem with this engine.
Carter. I just had a 27 milliamp reading a moment ago.
Okay. Are you going to teach your students how to do this in the fall?
That's my plan, yes. I'm planning on, I teach several subjects, and one of them is physical science, which is a freshman course. And the way I teach that course, the way I'm required to teach it in order to get all the standards and benchmarks in, I have to teach a trimester of earth science, a trimester of chemistry, and a trimester of physics.
Okay.
And so I'm wanting to incorporate this energy in with both the earth science trimester and the physics trimester. Because during the earth science trimester, we can learn about the water cycle, the carbon cycle, and incorporate how these sources of energy would reduce on the carbon dioxide load of the earth. then I would also be using during the cycle for physics how energy and power and electricity work, and how by harnessing the wind and the sun's energy, you can turn this into electricity into renewable resources.
Pretty exciting.
That then hence turn back and they hence then turn back and they affect the carbon dioxide cycle, hopefully reducing the load on that, reducing the load on electricity for everyone, cheaper electricity, renewable resources, rather than having to rely on fossil fuels and coal. Well, I should say coal is a fossil fuel.
Yeah.
In other words, you know what I mean, having to rely on fossil fuels.
Where do you teach?
East Buchanan and Winthrop, Iowa. I teach, I'm at the high school, so I teach at East Buchanan High School, grades 9 through 12.
Okay.
I teach AP Chemistry, regular chemistry, physics, physical science, a one-term astronomy course, and a two-term biology 2 class.
Okay. You teach all those classes I struggled with in high school.
I'm half of my science department.
That's impressive.
Yeah.
It's important then that you introduce this stuff, isn't it?
Yes, definitely. Well, the way the Iowa Corps is starting to move, especially going towards next generation science standards, wanting to incorporate those next gen science standards in the engineering and design component of those next gen science standards, I think this will be a perfect way to get them to work on designing things. I really try to incorporate a 5E learning cycle into my classroom, and I think projects like this would be the perfect part of the elaborate cycle where they're having to actually build and design something in order to take the concepts that they've already learned and have begun to, well, maybe not quite master yet, but this is a really good way to apply the concepts that they've learned. That's where I'm hoping to go with this.
Thank you.
You're welcome.